Okay, here's the solution video for part A of this year's lab assessment. Let's just read the preamble. A class washer-dryer implements the controlling software for a washer-dryer, that is, for a machine which can automatically wash clothes, followed, if the user desires, by automatically drying them. You might have been amused to hear the conversation between me and another staff member about what it was reasonable to assume students would know about washer-dryers. A class program is concerned with the different washing and drying programs that a user can select, delicates, cottons and linens, etc. You may assume that there is a navigable association from class washer-dryer to class program, with role name, selected program and multiplicity 1 at the program end. Okay, that's probably going to be about what things washer-dryer can be assumed to know about, isn't it? But we'll see as we go through. Okay. In Lucidchart, using its UML shapes, draw a nested UML state diagram for a class washer-dryer showing two high-level states washing and drying, that the initial state of an instance of washer-dryer is washing. Within the state washing, some stuff. Okay, we'll have to make sure we make the state washing nice and big. Then the next bullet point seems to be all about transitions. We'll come back to that in a moment. Final one, if the instance receives the event program finished from any state, show that the object's life is finished. Okay, that's also transitions, isn't it? But it's transitioning from any state to the stop state, to the end state. Okay, so let's start off by getting our high-level states washing and drying and our start marker and our stop marker sorted out. Okay, so here we are in Lucidchart with a blank diagram and some UML states. Let's have a state, a nice big state called washing. You might worry, and I did making this, about the fact that the label here appears right in the middle. I'm sure at some point I found a way to persuade Lucid to reposition the label at the top. I don't really care what you do. You can, provided it's legible, it'll be fine. So, you know, maybe you just make the state small and go down there, or maybe you make this label be blank and you put in a text label at the top. I don't really mind. It'll be fine. Okay. Now over here we're going to have our drying state. Okay. Now we need to have a start marker, that one. Oops, what's it doing over there? We wanted it over there. Okay, fine. Now, we want it our start marker connected to the washing state because the initial state is washing. I've done it that way because it's the state that has the doodad on the side that lets you draw out a transition. And now I'm going to reverse line direction because that's the easiest way to do it. There are other ways to do it. They're fine, provided it ends up looking fine. We're also going to need an end marker. Let's put that down here. We are going to need a transition from each of our states to it. I've already forgotten what the event that was supposed to trigger those transitions was, and I wrote the question. One thing to notice is, before I started the video running, I chose my standard, where was it? Set default. I did set default style with the arrowhead set to this one because this is the one we always want in state diagrams. If you didn't do that, you'll end up with the wrong arrowhead and you'll have to change them either one by one or doing the same thing. Okay, let's go back to the question and remind ourselves of what the event was supposed to be that triggered these transitions from washing and drying to the end state. Okay, program finished. Okay, so that's a very simple transition. It only has an event, it doesn't have a guard, it doesn't have any action. So let's put those in right now. Program finished. You're going to double click that. Going to go program -finished. And then I'm going to move that up so that it's not on the line. And the same here. Oops. I'm going to make sure that doesn't go over the line, it's just next to the line because that's how you do it in UML. Okay, so now what have we still got to do? We've still got to do our substates within washing, and we've got to manage our complicated transition. So let's go back to the question again. So on completion of, let's do our substates first. Within the state washing, the washing process does first wash, then rinse, then spin. Okay, that's nice and simple. So let's go. Have that one up there. Wash. Now I'm going to go Control C, Control V, Control V. So this one is going to be now rinse, and this one is going to be spin, and we're going to do first wash, then rinse, then... See, I'm not terribly expert with this tool, but you don't have to be either, provided it's roughly right. Remember, when you have a sub-machine, you do always have to say where it starts and where it stops. So you do need a start marker, even though they weren't explicitly mentioned. Given that we're not told what the actions are that take us between these states, and given the context, it seems reasonable to assume as well that these are just completion events that take us between these substates, so that's what we've got. Okay, now, what else do we need? Now we need to work on our transition from washing to drying. Now, what exactly was it? Let's move washing down a bit so that we can get that transition looking neater. I don't care about neatness, except for myself I kind of do. Okay, on completion of the washing process, so again we've got an implicit completion event going on to trigger the transition. If the dry attribute of the selected program has value true, so that's going to be, okay, it's going to be if selected hyphen program, this is where we need this information, dot dry, okay, and the weight attribute of washer dryer is less than 6, the machine should perform the action start dry and enter the drying state. And then there's an otherwise we have to worry about. Okay, so we've got no event because it's implicit, it's a completion event, but we do have a guard and we do have an action. Okay, so selected program dot dry and weight less than 6. Guards in square brackets, remember. Selected program dot dry and weight less than 6. That's the end of the guard. A slash following our action, preceding our action I mean, and I've already forgotten what the action is. It's supposed to be start hyphen dry. Okay. Oops. Start hyphen dry. Okay. Now, as per usual, we're going to move off the line. Let's also tidy things up a bit so that it's got space. There you go, make the marker's life slightly easier and make it legible. Okay, so that is our transition. We've got a guard, selected program dot dry and weight less than 6. You could go self dot weight less than 6, but self is always implied if there's nothing else. And start dry. Fine, good. Now, let us just go back to the question and check whether we've got everything. 2 high-level states, washing and drying. Yep. An initial state, which is washing. Within the state washing, first wash, then rinse, then spin, and appropriate start and stop markers, yep. On completion of the washing process, if the dry attribute of the selected program has value true and the weight attribute of washer dryer is less than 6, the machine should perform the action start dry and enter the drying state. Oh, no, we haven't done the otherwise yet. Good, okay. Otherwise, show that the object does no action and its life is finished. Okay. Otherwise, okay, so if this guard is not satisfied, it must mean we're going to go to the end state instead. Okay, so let's also have a transition to the, whoops, come here. We're going to have a, no, that's not actually quite proper. We really want that to go. Oh. Huh. That's annoying. How do I do this? Let's try this again. That's better. Why does it keep joining up? I don't want it to join up. That's fine, that's better. Good. Okay, now we need some text in here, and it's going to be the negation of that guard. So let's just do it boringly, shall we? Let's just go not selected program dot dry or weight greater than or equal to 6. That's the negation of that, right? We could do a not and brackets the whole thing, I don't care. But even at this time of night, I think I can negate an and. Good. Lovely. Now that really is finished for question 1. But let's go on and have a look at question 2. Add a note to your UML state diagram. In it, write an OCL class invariant in full, not just the OCL expression itself. Okay, so it wants the line that's going to tell us it's a class invariant. To specify that for any valid instance of washer dryer, okay, that's what class invariants do, the value of the attribute weight must be less than 10, and that if the dry attribute of the selected program is set to true, then weight must be less than 6. Okay, well that sounds quite complicated, but hopefully it's not really so complicated. We need a note. This is a note. Let's make it nice and big. And inside our note we're going to write context washer dryer inv colon, because that's how we say this is a class invariant. Now we're going to want weight less than 10 and selected program dot dry implies weight less than 6. Okay, now you might reasonably worry about precedence. You might want to say, is it weight less than 10 and selected program dot dry that implies weight less than 6, which would be a bit nonsensical, or is it the way you want it to be? And as per usual, we might just put some brackets to disambiguate, just so that nobody wonders about it. And now I've made that note really much too big, but it's fine. Okay. So now we really are all done, I think. Hopefully we've got our 50 marks for part A. What do we have to do now? We have to export the diagram somehow, don't we? Export the diagram as a.pdf. How do we do that? Over here. We're going to export PDF. Boom. Fine, and then I'm going to save it in some appropriate way, and then that will be done.